good day. Do you consider yourself a dummy, especially in subjects like physics? Well, you're not alone. This is basic fluid mechanics in 7 minutes. We will understand what needs to be understood about pressure, Pascal's principle, buoyancy, and Archimedes' principle. Let's get it, shall we? Pressure is a force applied over an area, where F is the applied force perpendicular to area A. Pretty simple actually. For instance, let's say you weigh 70 kilograms and you are standing still over a frozen pond with both feet planted on the ground. If both your feet have a total surface area of 500 square centimeters, how much pressure have you exerted on the ice? Using the equation showed earlier, it is force divided by the area. We are given the mass and the surface area, but how do we get the force? Quick review. Since you are standing still, force is equals to weight. In order to get weight, you multiply the mass of an object to the acceleration of gravity, which is 9.8 meters per second. So now that we have the force, all that's left is to solve for pressure, which is 13,700 pascals. Congrats, now you know how to solve for pressure using the given equation. But here's another question for a deeper understanding. Let's say you suddenly lift your right foot. How much pressure are you exerting on the ice now? Force remains the same, since you are still standing without any motion. However, since you are standing on one less foot, your surface area is half of 500 square centimeters. So the pressure is now 27,400 pascals. This implies that the smaller the area a certain force is applied to, the larger the pressure, and vice versa. So congrats, now you understand the basic concept of pressure. We will be moving on to a more complex application of pressure. Pascal's principle. Pascal's law states that pressure applied to an enclosed fluid is transmitted and diminished to every point of the fluid and the walls of the containing vessels. Phew, I know, what a mouthful. But basically this means that in any given container or situation, the pressure in the fluid is same throughout its volume. For instance, there is water that is 12 meters deep in a storage tank whose top is open to the atmosphere. What are the absolute pressures and gauge pressures at the bottom of the tank? But wait, pause. Gauge pressure is the excess pressure above the atmospheric pressure. Basically that means the pressure of whatever fluid there is inside the container. Absolute pressure is the total pressure, because as you know, air also has pressure, which is 101,325 pascals. So to answer the question, use the given equations. P gauge is the density of fluid multiplied to the depth of the fluid and acceleration of gravity. So the pressure of water is 1.18 times 10 to the power of 5 pascals. To find the absolute pressure, simply add the gauge pressure and air pressure. And voila, the absolute pressure is 2.19 times 10 to the power of 5 pascals. Basically, even though you are faced with a jar that has two different fluids of different densities, let's say oil and water, what you have to do in order to find the absolute pressure is, first, individually find the gauge pressures of each fluid. Then, you add them all together along with the air pressure, and there you go. Sounds real easy, right? Alright. Now we move on to buoyancy. We really about to feel the pressure now. Buoyancy is the tendency of a body to float when submerged in a fluid, though the object will only float if it is less dense the fluid. According to Archimedes' principle, when a body is completely or partially immersed in a fluid, the fluid exerts an upward force on the body equal to the weight of the fluid displaced by the body. This upward thrust is called a buoyant force. This is due to the difference between the pressure at the bottom of the object pushing up on it and the pressure at the top pushing down. Take note that the buoyant force has the same magnitude as the weight or force of the fluid displaced by the body. For instance, a 15 kilogram solid gold statue is raised from the sea bottom. What is the tension in the cable when the statue is at rest and completely underwater? Quick review. Tension is the force exerted by a rope, cable or any string-like object. In order to solve this problem, you must first understand the situation. There are many types of forces. Even if you are standing still, your weight is acting downwards. In this situation, there are 3 forces acting on the statue: weight, tension, and buoyant force. Since weight is going the opposite direction, it is subtracted from the total force. In order to find tension, the formula is rearranged and becomes tension is equals to weight minus the buoyant force. Now we have that part done, we will proceed to find the buoyant force itself. Using the formula, Buoyant force is equals to density of the fluid times volume of the object and gravity. We will now input the given values. But oh no, how do we find the volume of the object? Well, take note that density is mass over volume. So if the density of a solid gold statue is 1.93 times 10 to the power of 3 kilograms over meter cube, then the volume is 7.77 times 10 to the power of -3 meter cube. Using that, we can finally finish the equation. Therefore, the tension of the cable when the statue is completely at rest underwater is 68.6 newtons. Hooray, congratulations!
Congratulations! Congratulations! Congratulations! Congratulations!
Here is a cookie for making it this far. You really did good. Whether you are a math god or a student who is cramming an hour before the quiz, I really hope this helped you understand the basic concepts of fluid mechanics. Now good luck, young physicist, and
may the force be with you.